Hello everybody. Today we're going to be looking at acid, bases, and salts. How are we going to identify an acid, how are we going to identify a base, and how are we going to identify a salt? To make things really easy, reference tables handy would be the best thing to do because in the reference table we have the reference table K, which tells us that anything that is an acid would look like a formula like this, and hopefully we're noticing on this that this formula starts with H, this formula starts with H, starts with H, starts with H, has an H, has an H, has an H. Be aware that this formula down here on the bottom, carbonic acid, says CO2. Well, when CO2 is bubbled into water, a weird phenomena happens, so I'll show you what that is right now so we can kind of understand where they get the number from. If you were to merge this formula and this formula together, you wind up with a formula that looks like this. Two H's, so that takes care of that and that. You have a C and an O. Notice I have two O's here and one O there. That would give me H2CO3. So just be on guard that CO2 on its own as a solid liquid gas, pure substance, is not considered an acid because you're exhaling CO2 gas out of your mouth, and that is just the regular old compound. When mixed with water, if you were to bubble that into water, and you could try this cool experiment at your home, if you had some kind of indicator for your pool, you can simply take a straw and blow into the straw into a glass of water that has this indicator in it, and it will actually change color. So that's a proof that we can create carbonic acid from just breathing into water. Anyhow, that's how you tell an acid, and how you name an acid. We went over in our notes that if you have two capital letters, you'll notice the pattern is that you have hydroblankic acid. Okay, there's the hydro. There's the fill in the blank, whatever that thing that is attached to H is, and then blankic acid. On the other hand, if you have a more complex acid that has three capital letters, you just have to pay attention to what the polyatomic ion is that created it. In this one, if you take a look, you have NO2. This one you have NO3. This is nitrite, and nitrites get changed to us. Notice there's no hydro beginning to this, because when you have a hydro beginning, it tells you only have two capital letters. This is nitrate. So anytime you have something that ends with 8, you would change that to ic acid. So the root word of the polyatomic ion stays put, and you just either replace the ite with an us and the 8 with an ic. So that was all about acids. Now we're going to take a look at bases. Bases, naming them is pretty straightforward because there's only two pieces to a name. When you take a look at naming a base, you have your first name, which would be sodium, and your last name would be hydroxide. Again, potassium and hydroxide, calcium and hydroxide. But this one on the bottom here, aqueous ammonia, is the same idea as that last one we looked at with the acids. And I wanted to show you how this can cause confusion. If I was to take this and mix it in water and merge this formula all together, I definitely have one N. So let me get rid of that N right there. Get rid of that N. I have three H's here. So I'm going to take care of that H and that H by writing NH4, and look at what's left, NH4OH. So this forms a base when in solution. Basically, you have to bubble in NH3, the gas, into water to get it to create NH4OH. So when they say aqueous, notice the aqueous right here, that's why we're doing what we're doing. All right, and last but not least, a salt is nothing more than an ionic compound. Today, what our lesson is going to be all about is our lesson is going to focus prominently on how do you figure out the strength of something and its ability to conduct electricity. In our notes, we have said in a nutshell that acids, bases, and salts all conduct electricity. So that's a nice thing about this chapter is everything conducts in this chapter. That's part of the chapter title. But the degree to which it conducts, that's something that we have to figure out. So today we're going to look at a grouping of compounds and try to figure out what are we looking at. So the first thing that I do, if I take a look at number one on the top here, which I don't have numbers and my stylus is going absolutely bonkers here. So what else is new? I love it. All right. Anyhow, we got H3P. And hopefully, looking at this formula, you'll be able to determine whether or not this is an acid, a base, a salt, or other. Well, the first thing you do when you examine the formula is you notice that it starts with the letter H. All right? So if it starts with the letter H, we have to ask ourselves, is that an acid, a base, or a salt? And as you take a look here, we have acids all start with the letter H. So I'm going to say that this is an acid. That's for starters. Now, to figure out whether or not that this is strong or weak, I have to know a few things about these reference tables. Well, we have, I'm going to kind of highlight the strong ones for you. And the strong ones are when you have this type, H bonded to a halogen. Halogens are group 17 on your periodic table. The higher up on the halogens you go, it's where the strong ones lie. So pretty much HF. I would not want to spill that on my hands. That's an acid that if you spill it on your hands, it'll go right to your bones and start disintegrating your bones. Very, very dangerous acid. HCl is the acid found in your stomach. Obviously, it's a strong enough acid that if you were to lose some of your stomach acid on the hood of a car, it could damage the paint and get right through the clear coat. So something to keep in mind. You didn't know your tummy acid was that strong, did you? All right, HNO3 is also a strong one, and H2SO4. So we have HCl and HF would be considered the strong acids, HNO3. H2SO4. Now, please don't get confused between HNO2 and HNO3. They differ by one O. The one with the lesser O's is weak. So the ones that I've highlighted for you are the strong ones. When we move down to the bases pretty much if we have something that is connected to group 1 and OH, those are considered to be very, very strong bases. And last but not least, when we go ahead and look at table F for salts, these are all salts. So I'm just going to make sure that we understand that this is a chart for salts so that you don't get assaulted and not know where to go. All right, well, anyhow, anything in the yellow columns, that was a mistake there. I got to get rid of that. Whoops-a-daisy. Somebody was supposed to correct me out there. That's right. You guys are listening, but all right. When we have this, these are the columns, as you recall. These give us the AQs. So AQ. This gives us a solid precipitate and a solid precipitate, if you recall, from the double replacement reaction. And because of that case, all of these are considered salts. The solid precipitate has a small amount of ions still floating around in solution. So again, all salts conduct electricity, all acids conduct electricity, and all bases conduct electricity. Going back to the top, we have H3P, and we're trying to figure out now from this, can we tell whether or not H3P is going to be strong or weak? Well, it has to fit the criteria. If it's a binary acid with 2 capital letters, it has to be in group 17. Ask yourself, is P in group 17? And the answer is no way. it is not. So that makes this a weak acid. That's my way of trying to say weak, but my stylus is not being very cooperative today, but that's okay. All good. So, number 2, CuSO4. Does the formula start with H? No. Does the formula end with OH? No. Is it an ionic compound? Well, the answer is yeah, it's actually both ionic and covalent, but since the bar that I just drew to separate the Cu and the SO4 is the ionic part of this, yes, this is classified as a salt. So if I want to know whether or not this salt would be strong or weak, I simply go down to my reference table F, take a stroll down here. I'm looking at CuSO4. So here's SO4 right there. I'm going to say if it's any one of these, it's going to be insoluble, a solid precipitate. Cu is not this one, not this one, not this one, not this one, not this one. So CuSO4 falls right here. It's AQ. And since it is AQ, I'm going to say that it is strong. It is a strong salt. And my stylus went crazy again. There we go. All right. So strong. Next up, we got CH3OH. We're all thinking that's a base, right? No, it's not a base. That, hopefully remembered, is an alcohol. Anything with carbon, OH, okay? So generally when we look for bases, we are looking for bases in table L. We don't see any carbon OHs. The reason is mainly bases are predominantly a metal with OH. In the rare case that you have NH3, that's really, when we change that over, remember that's the same thing as NH4 OH. Okay, so this is the only rare one out of this whole thing. The rest of these, if you notice, they all are metal. All right. I got it right with my hand because this thing is just not working today. Metal plus OH. All right, and that's that. Going back up to the top, CH3OH is, since that is an organic compound, that's going to be classified as an alcohol. All right. I can't write over that line because if I write over that line, it's going to go crazy. Alcohols, and alcohols are going to be a non-conductor. So that covers that one. Okay, next up we got sugar. Sugar C6H12O6. That is strictly a covalent compound. So that is covalent. It's a molecule. And co, as you recall, is going to be a no-go when it comes to conducting electricity. Our next one that we have here is HF. Hopefully we realize that this is an acid. Okay. Oh boy. All right. HF. We got to ask ourselves, is F in group 17? The answer is yes. So it's going to be considered to be strong. That covers that one. Next one, CaOH2. It is a metal and a hydroxide. That's a great candidate for a base. We got to ask ourselves, is it a strong base? So how do we figure out if something is a strong base? We got to go to reference table L. It is a member of group 1. Well, Ca is not a member of group 1. And if you want to kind of cheat, you could also go to this reference table here, and you'll see that we have OH right there. All right? That's where OH would be found. OH is generally forming solid precipitates. But if it's connected with Ca, Ba, Sr, or NH4, that's when it would be soluble. But the bottom line is because it's not in group 1, this is what really takes precedent over predicting the base. Is it in group 1? The answer is no. So we expect that calcium hydroxide would be relatively weak. All right, so that covers the bases. CO2AQ. If we go ahead and recall, we found that in the reference table. That's the one that's sitting right here. Okay, that is an acid. And because it's an acid, and it is going to be weak. All right, and now NH3, if you recall, that is a base. It's on the bottom of the reference table. It is weak. And the last one that we have here, BaSO4, we have metals and nonmetals, and my gut is telling me that is a salt. So there we go, salt. Next thing I do is I always check your salts on table F. Table F, we're looking at BaSO4. Oh God, I gotta clean this mess up because we can't read that. BaSO4, all right, well, Ba is sitting right there. That means that it's going to make a solid precipitate. It's not going to be very soluble, so it's going to be weak. And that, ladies and gentlemen, is how you determine whether or not something is strong or something is weak. Hopefully that was helpful to you. If you have any questions, feel free to contact me, and I can do Google Meets with you.